It's a pleasure to be here. I know it's been a long day, so I will try and get to it and allow you to go and relax and enjoy yourselves. So I'm going to talk about a project that's joint with Andres Arosa, Luisa Fuster, and Georgi Kambarov. And you can see the title, Hours, Occupations, and Gender Wage Gap. So that very much describes what I'm going to talk about. But the presentation is going to be in two parts. The first part is basically going to be about hours and occupations. I'm going to present some data, try to suggest a simple model to help us understand the data that I show you. And having done that, then we're going to turn to talk about gender wage gaps. So I think I'm going to kind of jump right in here. I'm going to not necessarily follow Boyan's rule. I have no symbols here, but I'm going to jump straight to data instead of an introduction, so that I don't know if that's acceptable or not. So I want to show you some patterns between hours of work and occupation. And I'll just say as a minor piece of context for this, occupational choice and time allocation are two of the standard topics in labor economics. But interestingly enough, if you go to any undergraduate textbook in labor, there'll be a chapter or multiple chapters on time allocation, labor supply, and there'll be multiple chapters perhaps on occupational choice. But those two chapters actually don't talk to each other in the sense that the chapter on labor supply says that people just need to choose how many hours to work and how many hours to do other stuff, leisure, home production, whatever. So there's no mention of occupations there. And when you get to the occupational choice chapter, they say we have somebody who's decided to work and now they have to choose an occupation. So I want to start by showing you some data which suggests that these two things should be treated together. So the data we're going to rely on for this, all I'm going to show today is data from the US. I know that Jim and Susan are working on similar issues, looking at Swedish data. I think it's obviously of interest to expand this, but for today, everything is just going to be based on US data. We're going to rely on data from the CPS, the Household Survey, and we'll cover the period from 1976 to 2010. I'll also break it up into some sub-periods for later on in terms of some numerical exercises where we connect to the data. I'm going to focus on the period 1986 to 1995. We're going to focus on individuals 22 to 64. We'll also break it up into some 5-year periods. So for a data point is going to be inside one of these periods. We're going to look at an individual who only reports having worked in one occupation in a given year, and then we're going to look at the annual hours worked, which is going to be weeks worked times usual hours. And then we're going to look at a couple of summary statistics. So for each occupation, there's going to be at the three-digit level. For each of these, I'm going to report two statistics for an occupation. The average hours worked for people in that occupation, and the standard deviation of hours worked for people in that occupation. As a note here, for anybody who's worked with occupational measures over time, it's an unfortunate feature that they keep changing the definitions. We're going to rely on the work of Otter and Dorn to link those consistently. So here's the main picture I want to show you. This one is just for males. I'll also show you for females in a few minutes. And again, this is for the period 1986 to 1995. I'll note that it's because I'm looking at these two statistics, the mean and the standard deviation, in particular, because one of the statistics I'm looking at is standard deviation, it's important to actually have a fair number of observations in the bin. If you have too few observations, you're obviously going to get a pretty noisy measure of the standard deviation. So we actually throw out observations with less than 30 in a bin, which for males doesn't actually eliminate very many. But one of the reasons why we have to expand the time period a little bit is to pool the observations to get the bin sizes. But what you see here, which is kind of striking, there's a weighted regression line in there. is that you see occupations line up on this downward sloping this downward sloping relationship, that the top left here are occupations which have both high average hours worked and also small dispersion in hours worked. And as you go down to the bottom right, you've got lower average hours and bigger standard deviation of hours. One thing I want to point out is just the magnitudes of those differences. So just, I'll actually show you some numbers later on where we're going to split all of these occupations up into 2 bins. If I did that here, rank them in terms of the mean hours, put them into the 2 bins and computed the averages, the difference between those is 25 log points. And that, I think, is kind of an interesting number, because if anybody has worked on the cross-country differences in labor supply literature, then 25 log points is kind of the difference between the US and France, which is a huge number. And you get those same types of numbers just looking at differences across occupations in this data. And the differences in standard deviation are also large. So that's the simple plot, and that plot by itself, I guess, kind of suggests that there's maybe some interaction between labor supply decisions and occupational choice, which is what I alluded to before. What I'll show you next is kind of some robustness types of pictures, just in terms of what's going on. So the first thing I'm going to show you is that if you look at 5-year subperiods, all the 5-year subperiods we have there, you basically see the same type of relationship. So this is not something that's unique to that one time period I showed you. You actually see this in all these 5-year time periods. In terms of what we're going to talk about later on, I actually want to think that there's something about an occupation that places it in a particular place on this type of scatter plot. In terms of what I've shown you now, I've shown you we get the same pattern in terms of the dots, but I haven't shown you that a given occupation tends to stay in the same place. So what I'll show you next is 2 pictures to try and convey that idea. So the 2 top graphs here are basically showing you where occupations are in terms of the average hours of work across different 5-year subperiods. And if these are on the 45-degree line, that means you've got basically a fair bit of stability there. And as you can see, those 2 scatter plots, they're not right on the 45-degree line, of course, but they're kind of along the 45-degree line. The bottom 2 are the same thing for the standard deviations. Once again, those kind of lie along the 45-degree line. There's a bit more of a cloud with the standard deviations, but I would say that's somewhat to be expected, just because we expect more noise in terms of measuring the standard deviations across these samples. So again, all I want you to take away from this is there seems to be something about occupations that there's a connection between some measures of hours of work and occupations, and they seem to be stable over time. This is just showing you, if we look at the distribution of men across occupations, where here I'm going to characterize them either by their mean annual hours or their standard deviation. That distribution has really not changed too much over time for men, going from 7680 to 2006-2010. Now let me show you similar pictures for women. So here what we've done here is sorted the occupations according to the mean annual hours by men. And then the blue curve on the left is showing you the smoothed distribution as we go across the more than 300 occupations in terms of, and each red dot is the corresponding dot measure of mean log annual hours for women in that occupation. And what I want you to take away from that is the red dots kind of follow the blue line to first approximation, but it's shifted down. The right curve is doing the same thing except for the standard deviation. And here, once again, the red kind of follows the blue, but it's everywhere above. So although we see similar qualitative patterns in terms of what's going on across occupations for men and women, within each occupation, typically women work fewer hours and they have a higher dispersion. And for women, there's actually some interesting changes over time in terms of that distribution. So in this graph, the blue is for the men in 2006 to 2010. The red is for women in 1976 to 1980, and the green is 2006, 2010, and first approximation. Over that 35-year period or 30-year period, women have kind of closed about half the gap with men in terms of those distributions.
Does this include women who don't work and zeros?
No, a zero, because if there's zero, then you don't have an occupation. So this is conditional upon having a single occupation for the year. And the last piece of information I just want to show you, and again, this is just a correlation. I'm not claiming any causation here, but I just want to show you that in fact there is a correlation between average, this is wage per hour, this is not earnings, wage per hour, and the occupation sorted according to average annual hours worked. And for men, you see on the left, and for the right is plotting the same thing for women. And you see that for women, you get the same type of relationship, but wages are everywhere lower for women. So that's what I want to show you in terms of some facts. So as I said, right now I don't want to talk about gender. Right now I just want to talk about what type of model would help us understand that pattern we see between occupations and labor supply choices. So to do this, I'm going to suggest a particular simple model, which I think of as a modified type of Roy model. So I think as a starting point, it's natural. If you're thinking, I want to think labor supply and I want to think occupational choice, why not take the two kind of benchmark models? So the labor supply choice is just going to be people value consumption and leisure, and the occupational choice model will be a Roy model. So just to keep things simple, I'm just going to do everything with two occupations here. We could talk about generalizing it, but everything I talk about from now on is just going to focus on two occupations. So let me write down that type of model. So I'm going to have a unit mass of individuals. The model I'm going to describe, I'll describe it kind of as general equilibrium. But you'll see because of the specification, there's a sense in which there's no real general equilibrium going on here. Related to what Boyan talked about yesterday, the assumptions I'm going to have on technology, I'm going to have linear technologies, which basically means the skill prices are going to be pinned down without knowing anything else. If I had some curvature there, then the skill prices would also be endogenous. So in terms of individuals, a unit mass of individuals, individuals are going to value consumption and leisure. I'm going to have the log C there as a typical macroeconomist, offsetting income and substitution effects. That's not necessary. I actually think that's a good benchmark, so that's why we're going with it. You'll also see how it affects some of the expressions, but I don't want to claim that that's an essential ingredient in any sense. So consumption, time endowment, hours of work. Then the Roy model component, as I said, there's going to be two occupations. Each individual is going to be endowed with a pair of productivities which tell you how productive they would be if they went into occupation 1 or occupation 2. I'm also going to add one additional source of heterogeneity. I'm going to make phi heterogeneous across individuals. And the reason I'm doing that is anybody who's tried to understand variation in hours in the cross-section, which is going to be one of the statistics we're very interested in here, knows that if wages are the only source of heterogeneity, you're kind of fighting a losing battle in terms of fitting the data, because there's just not enough correlation between wages and hours worked in the cross-section for that to be enough. So we need at least one other source of heterogeneity distinct from wages, and so I'm just going to load all that into heterogeneity in the phi parameter. Okay, so that's the on the technology side. I'm going to have two linear technologies. We could have added another layer here. We could have, maybe in the spirit of the more recent literature about thinking occupations and tasks, we could have had an aggregate production function where each occupation provides some tasks into that aggregate production function. This is just like assuming we've got perfect substitutes between those two. So it's just a special case. And it's because of that linearity that we're basically going to pin down skill prices in the competitive equilibrium. So that's the output from each of the two occupations. EJ is the total labor services supplied to that occupation. Now in the standard Roy model, if an individual with productivity A1 in occupation 1 worked H hours, they would supply A1 times H efficiency units of labor. So I'm going to consider a modified version of the Roy model, and the modification is we're going to allow for some increasing returns to scale in terms of the mapping from individual hours into efficiency units. And so I've got the expression there. If individual I works in occupation J, the efficiency units that they offer is going to be Aij, and instead of just multiplying by H, it's going to multiply by H times to the 1 plus theta J. Okay? And so theta J equal to 0 is kind of the standard Roy model. We're going to add the increasing returns there. I want you to actually think of this model, although, I mean, it's a static model, but I actually want you to think of, when I talk about occupational choice here, I want you to think about it really as a career choice. So this is really what they're going to get over their lifetime. And from that perspective, there's kind of two different factors which feed into that, where those increasing returns are coming from. One of these is a static factor. There's actually a sizable literature which has looked to see to what extent there's a causal effect of hours on wages per hour. That's a tricky question, tricky thing to get at in the data, of course, but there's a literature that has tried to do that. And a consensus, I'll say a consensus estimate for people who know that literature is that the theta for that static part is equal to 0.4. But there's also, if we're thinking career, there's also an important dynamic component, and the simplest way to think about the dynamic component is if there's any learning by doing in terms of human capital, because that means hours that you work today influence your productivity in the future, and by virtue of that, you actually have increasing returns in terms of the mapping from hours to the average wage per hour. And I'll talk about that a little bit. So I think there's lots of evidence to motivate the fact that having a positive theta there is a reasonable thing. What's going to be critical for the view that I'm going to suggest here is that the theta is going to be heterogeneous across occupations. Now I'll say I think there's a lot of suggestive qualitative evidence that that's reasonable, and just by introspection you might also think that's pretty reasonable. But two different things you might think about. First of all, in terms of the static component there, one way to think about that is there a penalty for part-time work in a given occupation? And there's a literature which has tried to estimate that. And one of the facts that comes out of that literature is although on average there is such a penalty, it also differs across occupations. So that type of evidence would suggest heterogeneity in theta. Then if we think about learning by doing, and in particular, thinking about accumulation of occupation-specific human capital. Somebody today mentioned the Kambarov and Minovsky paper and occupational specific human capital. So if we think in those terms, there's now a fairly active literature which tries to estimate those types of occupational returns, returns to occupational tenure, and that literature definitely finds a fair bit of heterogeneity across occupations in those measures. I don't want to claim that that literature has kind of definitively estimated those differences, but when people do the simple kinds of exercises, they do uncover differences. So all that's going to motivate differences there. Just to keep things simple, we're going to put theta in occupation 2 equal to 0. We're going to call it the linear occupation, and then we'll have a positive value of theta in occupation 1, and we'll call that the nonlinear occupation. When I later on talk about gender gaps, I'm going to refer to Claudia Goldin's Ely lecture. I don't know if many people here have read that or heard it a few years ago at the AA meetings in Philadelphia. But this language actually maps exactly into the narrative that she told about the differences in occupations, that some are linear and some are nonlinear. So that's just talking about the differences there. So now I want to talk about the extent to which this framework can help us understand those patterns I saw. And there's actually a delicate issue here in the following sense, that in some ways it would be, so I kind of added something to the basic Roy model. I added these increasing returns. So it might be nice if I told you that we actually need those to explain those facts in the data. It turns out we don't need theta to explain those facts in the data. And that's because whether it's a good or a bad feature, the Roy model, although simple, is actually very rich in terms of the types of things it can generate if you don't put any a priori restrictions on the heterogeneity. So in particular, without any thetas, you give me whatever data on a bunch of people, tell me what occupation they work in, how many hours they worked, and what their wage is, and I can nail that with the Roy model. I'll basically, you tell me how many hours are worked, that's going to pin down the value of phi, their heterogeneous taste for leisure. You tell me their wage, and that will tell me what the A is in the occupation in which I observe them. And then I just make the A in the occupation where I don't observe them sufficiently low that they don't want to work in that occupation, and I'm done. So there's no sense in which we need the thetas, but I'm going to, based on what I've told you, I think it's reasonable to think that thetas are there and they're heterogeneous. And so I want to say, if I just wanted to see how far I can get with thetas without playing around with those types of Roy things, how far could we get? So just to, what I'll show you first, and this I think is not going to be too surprising, I'll show you that qualitatively this model, this extra feature of the heterogeneity in the increasing returns across occupations, that's going to be enough at a qualitative level to generate the types of patterns we see in the data. And to show you that, this is the optimization problem that an individual would solve in this problem. They have to choose which occupation to work in. We're going to use an indicator function, I equals 0 or 1 for that. And then conditional upon an occupation, how many hours to work. With this setup, they would always choose to allocate all their time to one occupation or the other. So we don't have to worry about somebody mixing. The expression at the bottom here is the first order condition for conditional upon working in occupation J. This would tell you the optimal hours worked. One thing to note there is the A, the productivity, does not enter there. That's because of the assumption of offsetting income and substitution effects. Again, we could deviate from that, and then the A would appear there. But the reason it doesn't appear here is because of that. The right-hand side here is just a function of H. The left-hand side is a function of the occupation and the individual taste for leisure. Here's a simple picture from which you can read off what the optimal hours are for the two occupational choices for an individual with a given value of phi. So the right-hand side of this equation turns out you can show that that's convex, and so that's the convex curve. And then to find the optimal hours, you basically say what's the value of that left-hand side, and then you just draw a straight line across at that value, and look at the intersection, drop it down to the x-axis, and that's your value of h. And 1 plus theta over phi is always bigger than 1 over phi. And from this picture, it tells you that for a given individual, if they go to occupation 1, they would always work more hours than if they went to occupation 2. No big surprise here. We have a model in which the return to working more hours is bigger in occupation 1, and sure enough, they work more hours in occupation 1. So this is not any big deal. It's kind of obvious. This is just showing you the obvious. What is maybe less obvious at the outset, but once you see the picture is pretty obvious, is the model also implicitly has a force which is going to give you more compression in the occupation 1, the nonlinear occupation, and the linear occupation. And to see that within a given occupation, the source of heterogeneity of hours is going to be differences in phi. But in occupation 1, the nonlinear occupation, the intersection is going to be at a steeper part of that G curve. And so as you change phi by a given amount, the implied variation in H is going to be less in occupation 1 than in occupation 2. And so this simple picture tells you that qualitatively, heterogeneity in theta is going to naturally lead to higher hours in the nonlinear sector and also more compression.
In the data, full occupation is a big phenomenon.
So there's so a couple things. So obviously people do change occupations. So in that sense, in a given year, anybody who changes occupation partway through the year is going to have multiple occupations. If we talk about people with multiple jobs, and then how many of those jobs are multiple occupations, there's obviously some of that. In terms of the way I'm going to aggregate the data here into 2 bins, then there's going to be a lot less of that because many of the people with multiple jobs are going to be multiple occupations that in the end I put in the same bin. Okay, so that's qualitatively. So now I want to ask the question. I already told you the Roy model by itself could match whatever numbers you give me in the data. I want to ask how far could I get quantitatively with just kind of relying on this mechanism. And so the way I'm going to try and persuade you of that, obviously theta is in some sense, the key parameter here. So one thing I could do is I could show you a plot somehow where I change theta, and as I change theta, I tell you something about the ability of the model to account for the differences in terms of occupations. I'm not going to show you that picture. I'm actually going to focus on, I guess, one other feature of this model, which I actually should have mentioned. If you had a Roy model without the increasing returns heterogeneity across sectors, the choice of which occupation to go in would be independent of your taste for leisure. You go into the occupation where your A is highest, and then phi just tells you how much you would work conditional upon that occupation. In the model with heterogeneity in the increasing returns, it turns out that your occupational choice depends not only upon your values of your A's, but it also depends upon the value of your phi. So 2 individuals who have the same A's but different phis could end up making different occupational choices. So I want to, rather than show you a whole bunch of values for theta, I'm going to focus on one particular value. Again, ideally, I could tell you that I think I know what the right value of theta is to focus on. I'm not going to argue that. And because time is short, I'm just going to say that based on kind of back of the envelope calculations, based on some of these results I told you about differences in part-time penalties across occupations and differences in the return to occupational tenure across occupations, I'm going to claim that 0.6 is kind of not is actually, I think, a reasonable and somewhat conservative value. Later on, assuming I get to some of the results at the end, I'll actually show you some sensitivity for theta going from 0.4 up to 1. But for now, I'm just going to show you 0.6 and just humor me and accept that 0.6 is not a ridiculous value to focus on. So what I want to do here is ask, with theta equal 0.6, and not relying on the Roy model at all in terms of generating asymmetries across occupations, how far would this get? And so I want to specify the Roy part of the model so it's kind of neutral in terms of occupations. And the way I'm going to do that, I'm going to have everything uncorrelated, all of the individual specific parameters. I'm going to have the variances of the A's be the same across the 2 sets. So everything is going to look kind of neutral in terms of the Roy model. So all of the asymmetry across occupations is going to come from the theta. So I'm going to choose the Roy model parameters so that in the aggregate, I get the right amount of variation in hours, I get the right amount of variation in wages. I'm going to also choose it so I get half the people in each of the 2 occupations. So those are the values that come out of that. Then this is what we get in terms of the data and the model. And again, the data here, I've taken all those occupations, put them into 2 groups, basically sorted, ranked them by average annual hours, and then made it so there's equal mass in the 2 bins. And what you can see here is if you look at the difference in mean hours across the 2 occupations, with theta equal 0.6, we're basically getting pretty much all of that. In terms of the differences in the standard deviations, we're getting about 2/3 of that. So Fabian is not here, but Fabian actually discussed this paper at a conference a couple months ago. And one of his points was that the estimate of standard deviation that we have in the data, we should really think of that as something bigger than what we actually are trying to match. And one reason for that is that one source of heterogeneity in hours in the data is that some people have unemployment spells during a given year. This model does not have any of that kind of frictional stuff going on. So the fact that we get 2/3 might actually be a good thing in some sense. But anyway, all I want you to take away from this is that with theta equal 0.6, which you're going to humor me and say you're going to allow me to proceed with theta equal 0.6 is reasonable, the forces just from this asymmetry go a long way to helping us understand not just the qualitative differences across occupations, but also the quantitative differences. That by itself does not get too much of the wage differences. It only gets about 17%. And I say that, in a sense, doesn't worry me at all, because if anybody's worked with Roy models, people know one of the things Roy models can easily do is generate some wage gaps across occupations by getting people to sort based on their unobservables. So in particular, if the two productivities are positively correlated, but there's a higher variance in the nonlinear sector, the Roy model is basically going to get the more productive people on average are going to tend to go to the nonlinear sector, and so that would also easily generate some wage differences. So that's the end of well, I guess the last thing I'll just show you here, which comes out of this, is there's also this selection effect that people with high values of fee, people who value leisure, are disproportionately in the linear sector. So that's the end of the first part of the presentation that I talked about. And what I want you to take away from this is simply that if we want to think about occupational differences and labor supply, a good framework seems one in which we kind of take the Roy model, but we supplement it with this heterogeneity in increasing returns across occupations. That seems a useful way to think about this. So now I want to...
So how do you square the fact that supposed occupations are also for the high skill occupations? And we know that the high skill occupations get higher wages and they get a high variance in wages. So you're saying that's not only from hours at all.
Actually, that's what you said is, if you look at standard deviation of log wages here, they're pretty much the same in the data.
There's all these the Mells and the usually say that the variance of wages is much higher for high skill parents.
It's not true. I mean, all I can say is it's not true by occupation, but I mean, so I haven't shown you education here, but it's certainly true that there's a correlation between education and the nonlinear occupation. So maybe it's a bit surprising that's not there, but in any case, it's not there in this cut of the data.
So you can do this whole table separately for high school and low school?
Well, again, we're doing this by occupation.
Yeah,
So then within an occupation...
I make a choice and somebody else makes a choice. So if I have just high school, not even high school, then I have different choice sets.
Yes. Well, so there's many senses in which this model has a lot of slippage in connecting to the data. So we have no notion of education here, but one abstract way of thinking about this is these A's we have are really conditional upon going into an occupation. This is what you're going to end up with, but you have to kind of think that's net after whatever you might have to do in terms of getting some schooling for that. But if you actually take me too serious on that, that'll create some other problems, but that's at this level, that's what I would have to say. So it's kind of embedded in those A's, loosely speaking. So again, that's the first part of the presentation. Now I mentioned earlier Claudia Goldin's Ely lecture. So let me show you. Again, she talked a lot about asymmetries in terms of labor market outcomes, and one of the things she stressed was occupational differences. So here, with the same split of occupations into the two bins, here are some numbers you see for males and females. And what's quite striking here, you can see that males kind of are 60-40, nonlinear, linear, and females are kind of 60-40 the other way. You see that in the aggregate, women work fewer hours than men, but they also work fewer in each of the bins. These are facts I kind of showed you in the picture. The standard deviations are higher for women. They're higher in each occupation. Wages are lower for women, but they're lower in each occupation. Interestingly enough, standard deviations here are kind of the same for men and women across occupations. So these are kind of the numbers that are in the background. And if you read Claudia Goldin's paper, and she's saying these are kind of things we should be thinking about in terms of trying to think about factors which cause asymmetries, that these are kind of interesting numbers to have that you're trying to account for. And so in these numbers, of course, occupation plays a big role. And some of the facts that we have there, the model that I just proposed kind of seems like a natural model to speak to this. So the next thing we want to do is extend our model to have gender. We're going to do that by having 2-member households, 1 male, 1 female, and just generalize it naturally in terms of that. So the husband will have productivities like the Roy model. The wife will have productivities like the Roy model. They'll each have a preference, taste for preference. We'll have to talk about the extent to which there's assortative mating of types in terms of things. But we want to use that model to think about what types of factors might help generate these types of patterns. So one of the factors that Claudia Goldin talks a lot about is the fact that women have a lot more responsibility for non-market types of household activities. And because of that, they have more demands on their time and more constraints that they face. And because of the fact of these differences in occupations in terms of the return to working additional hours, those extra constraints feed into occupational choice, et cetera. So what we want to do next is basically take our model, calibrate it to data, and we're going to ask the following very simple question. We're going to say, suppose we just take seriously that women have less time available because of more duties that they do non-market. So we're going to not ask why that is. So in some sense, we're going to talk about the proximate causes of these asymmetries, not necessarily the deep causes, but just taking as given that that's one asymmetry between men and women. And interestingly enough, it's a non-market asymmetry. We want to ask how big of asymmetries might we expect to see in terms of market outcomes. Now, one way you could do that is build a huge model that you think is a model of everything, estimate it, and then this will just be like a piece that comes out. We're not going to do that. The spirit of what we wanted to do was basically the following hypothetical. Suppose men and women were exactly identical in a distributional sense, because we've got a lot of heterogeneity among men, a lot of heterogeneity among women, but suppose they're identical in a distributional sense, and the only difference was that women need to allocate some extra amount of time to non-market activity, which in our framework we're going to think of as they have less discretionary time. We want to ask, when you feed that through our model, what would you expect to see in terms of asymmetries, in terms of outcomes?
Is that going to give you a gender gap? Is that why women are going to earn less?
Yes.
Because that's a little controversial. No? Or like if you claim that the wage gap is there just because women sort of like have less time? Like, is there evidence for that?
This is going to be the evidence. I mean, suppose you, so first of all, so as a factual matter, you can go to the time use survey and see that women devote more time to home production. So just as a factual matter, we know that asymmetry is there. And I say, I'm not going to talk about why that asymmetry is there, but given it's there, it may have some, in this model, it will have some consequences. So just qualitatively, what time, are you keeping track of the time, by chance? I'll take a look at the time. Okay, I'm supposed to stop soon, so I will stop soon. But here's, I'll tell you,
You had 3/4 of an hour.
Yeah, if you take this model, what are the qualitative effects here? So The first thing is if women have less discretionary time, they're going to have less time left for market work. The simple mechanics of this model, I already told you, if you've got less time for market work, at the margin, you're less likely to go into the nonlinear occupation. So there's going to be a direct effect on occupational choice. And this, again, if you read Claudia Goldin's paper, this is like one of the big themes, that this is a potentially important factor in occupational choice. So this is an attempt to just say, put some detailed structure there, as narrow and specialized as is, and let's just get a sense of how big a numbers would come out of that. So that's what we're doing. So that effect is pretty obvious. In addition to affecting occupational choice, this is going to affect hours of work. And for anybody who does go, any woman who does go into the nonlinear occupation, the fact that they still will on average work fewer hours because they actually have smaller discretionary time, given that there's increasing returns in that occupation, they're going to have a lower wage on average. So that's going to generate a wage gap. It's going to distort occupational choice, and it will directly generate a wage gap in the nonlinear sector. Now, if you...
One wage gap not controlling for education, and another wage gap when you control for education.
Again, education's a little... At the level here, because these are two bins, so it's, yeah, occupation, yes. Now, you might think at first pass that that's the only wage gap we're going to get in this model, because all the action is going to be in the nonlinear sector. There's no nonlinearity in the other sector, but in fact, that's where the selection problem comes in. And the reason there's a selection problem, as I said before, is because the occupational choice is distorted. It means that women, many women end up in the nonlinear sector, not because that's where they're most productive, but it's driven by the fact that they actually have lower desired hours of work, and that pushes them into the linear sector. And that selection effect depresses the average unobservable characteristics of women in that sector and also reduces wages there. So qualitatively, this model is going to generate a wage gap in the nonlinear sector, a wage gap in the linear sector through very different mechanics, and distort the occupational choice. So qualitatively, it kind of can generate the types of things I've shown you in the data, but how big are those numbers? So I'm going to spare you the details there, but the spirit of our calculation is to basically calibrate the model so that we match everything for men, and then we just impose that women look like men, and then we add in this gap in discretionary time, which we think of as roughly 10 hours a week or 500 hours a year. And then we solve the model. And so there's some extra stuff there. I'll tell you the reason there's some extra stuff there is if I just did that calculation, there's a sense, so I'll tell you if I just did that calculation, I'm going to find that those magnitudes are kind of sizable. There are no sense all of the gaps we see in the data, and there was no reason to think this was going to be all of the gaps. The question is this just like a sizable piece, something that, an important factor? I'm going to say we get differences of a wage gap overall of something like 9 or 10%. It turns out some of that's kind of equally coming from a gap in the nonlinear, a gap in the linear, and an occupational composition. The occupational composition is large, but if that was the whole thing, you might think that we've overestimated the differences, and the reason for that is if I said that men and women are identical except for this difference in discretionary time, and then what I generate is a wage gap of about 10%. I've actually, the wage gap in the 86 to 95 period between married males, married females is actually roughly 40%. We're missing 30% of the wage gap, and you might have the following concern, that 30% of the wage gap that's not in our model, if we just fed that in our model, that would have its own large effects. And then maybe this discretionary time is kind of small potatoes after you've already got that effect there. Because in the context of a family model, of course, if women have lower wages, they're going to work less. Because they work less, that's going to distort their occupational choice. You might think we get all those effects, and then adding on this discretionary time thing is kind of a lot different. So the numbers here, we actually added an additional wedge. We lowered the female productivity distribution proportionately. And then going from the second to the last column is basically telling us in this framework with those extra features, what was the effect on the wage gap. You see we get an 11% wage gap just by the difference in discretionary time, a 33% difference in hours worked, and a 17 percentage point difference in occupations. So I think those are all kind of sizable differences. It's in no sense like the single biggest piece. It's like a quarter of the overall wage gap, but I think 10% from that is actually something pretty sizable. And I'll just emphasize that there's no sense in which this is the final answer. The model is very simple. We already had one discussion about some of its limitations of connecting with the data. You might say, let's actually have a true life cycle model and follow the choices over time, et cetera. But this is kind of a simple calculation to say, does it look like there's something there? If we kind of got nothing there, then maybe it's not worth filling in all those details. I take this to mean it looks like there is something there, and then probably it is worth to fill in those details to fine tune it. And I will stop there.
Thank you for your questions. You may start. Other people, questions?
I think they want to know where are drinks.
I'm still not convinced by your education. So why don't you separate? So you say education, your answer is education is indulgence.
Yes. I mean, I think we want to think education is because it's very hard to be a doctor without getting the education to be a doctor. So to the extent doctor is one of the occupations, implicitly, to be a doctor, this has to be what you have left over after you get the education.
But only two counter arguments. One is obviously ability that differs in some people can do the education. So part of the education is probably ability.
Well, that's all embedded in A, because A is going to be what's left over. So if it's very difficult for you, then there'd be not much left over by you. So, but just to, would it be nicer? So this is so simple. Would it be nice to add the life cycle instead of just kind of doing one period? Yes. Would it be nice to add an explicit education, because that links to some of the occupational choice, and actually have the parameters for that? Yes. So I'm not trying to argue we don't want that, but right now we don't have it, but this is how one would think it's embedded in there in the current form. But I'm not saying that's a good way to do it.
You said you talked about marital sorting.
Oh.
Is that for you then?
So we used data from the PSID. So we got the correlation between spousal hours and spousal wages, and we matched those. We used assortative mating, helped us match those moments. So that's the sense in which and I'll say it turns out that the degree of assortative mating is actually important in a quantitative sense. So one point I didn't mention, but I should have mentioned, is first of all, the family structure actually amplifies these differences. So anybody who's worked with family models knows that there's some substitutability in terms of generating income. And that means that anything which kind of depresses things for one member creates an opposing effect for the other member. And so the fact that women are not going to work so many hours, that has a feedback effect on the choices of men. It makes it more likely that men go into the nonlinear occupation where they would work long hours because there's less income being generated by the female. How much substitutability there is between male and female time across occupations depends upon how similar they are. If the male and the female are very different, one of them is only good in the nonlinear occupation and one is only good in the linear occupation, you don't get that much. But we actually have a fair bit of assortative mating, and so that's quantitatively matters. But a basic point is that we've actually done the same exercise where we think of everybody being single. So you could give women less discretionary time, but be single, and the effects are much muted in that case. So the family structure actually amplifies the effects of that difference in discretionary time. Okay.
We are allowed to have Princeton.
Okay, thank you.